This is the 2.6 to 2.9 review, number 2, and again, calculators are not allowed. This problem is a little challenging for some people because we want to come up with different expressions involving limits that would give us the value of the derivative of f at 2 for some differentiable function f. So what we have to do is think about how we developed the derivative of that develop the definition of the derivative of f at a specified point. So if we remember, we had some function f, and now we're going to choose the value 2 and label that point to f of 2. Now if you recall, we wanted to set up some sort of a slope. So we had to choose a second point, and then we could label that point however we chose. So one of the ways that we can choose to label that point is x f of x. When I do that, I can set up a secant slope, which would be y minus y over x minus x. And then to create a tangent slope out of it, I need to move this point x until it collapses onto the 2. So I can illustrate that by putting the limit as x approaches 2. Now variations on the theme are, I could do the limit as x approaches 2 from the right. And as long as that limit exists, it's going to be the same as this limit. As long as the two-sided limit or the derivative exists, since the function is differentiable, that tells us the derivative exists, then this right-hand limit is going to be the same as the derivative at 2. By the same token, we could do our left one, and this again would be an option. Another variation on the theme is, instead of having x f of x be the first point, I could have 2 f of 2 be the first point, and then subtract the x's. This again will give us the derivative. Notice that I could do a right and a left, so I won't waste time writing both of those again. Now another way to look at this is, instead of labeling it as x f of x, we can say that the distance between these 2 points is h. So now my x coordinate is a 2 plus h, and my y coordinate would be an f of a 2 plus h. So I could set up the limit as h approaches 0 of my right x, or my right y coordinate minus my left over my right minus my left x coordinate. When I do this, we will get that definition that we are accustomed to seeing, the f of 2 plus h minus f of 2 over h. And again, just like up here, I could approach that 0 from the right, or I could approach that 0 from the left, and they will both generate the same answer provided that derivative exists. So this takes care of most of what we see here on the answer key, but we do have one other variation that I want to show you. And that is, what if I have my point at 2, and instead of using 2 as my initial point, I'm going to move h units to the left and h units to the right. So this is kind of like when we flank points in data. We can do the same sort of flanking action when we have the function. So this one would be a 2 plus h comma f of 2 plus h. And this one would be 2 minus h f of 2 minus h. So if I set up my limit now, there's my secant. I want the slope of that secant, so it could be y minus y over x minus x. If I simplify this, I end up with an f of a 2 plus h minus an f of a 2 minus h over, make sure we look here, we're going to have the 2's cancel and the h's will collect to become a 2h. Now this is still a secant slope. In order to create a tangent slope that will equal f prime of 2, we need both of these points to collapse down to 2. So that means this value of h and this value of h both need to shrink until there's nothing left. So if we put a limit as h approaches 0, we can see that this y coordinate will approach f of 2, and this y-coordinate will approach f of 2, just as the x's will approach 2 and the x will approach 2. So this is called your symmetric difference quotient, and this shows up, this is used quite a bit in your calculator programming because it's a very efficient, quick way to get down to that numerical derivative. So when we look at these, all the different variations on the test, it's going to be a multiple choice problem. So I'm going to be looking to see whether or not you can identify that we have a point here, there's an x-coordinate and there's a y-coordinate. If you can see the other point with the x-coordinate and the y-coordinate, and then you have to test to see if one of the points is colliding to the other and that x-coordinate corresponds to the one we want the derivative at. So if we look here again, you can see that the x-coordinates are 2 plus h and 2, so on the bottom I better have a 2 plus h minus a 2, and that's where the h comes from. Here if we look, we have an x-coordinate of a 2 plus h and another x-coordinate of a 2 minus h. So if I subtract a 2 plus h minus a 2 minus h, that's going to generate my bottom. So we can see I've got a y-coordinate minus a y-coordinate over those interior x-coordinates subtracted on the bottom. Then the last thing you have to check is that the limit indeed causes both of those points to approach the 2. So hopefully that's enough of variations for you to kind of see how this problem is going to work on the test.